Thank you for making the technology work. Uh, Thank you for coming out, guys. We really appreciate everybody who came out this afternoon. It's never easy. LA traffic is LA traffic. We all know it, so I'm not going to talk about it. But we appreciate you taking time, taking an effort to come out. The intent of this meetup is to be educational and help you. We have two very senior gentlemen here. One, Prasad. He's been in the industry, data engineering, for about 15 years, so plus more than a decade. And then we've got a gentleman here who just reminded me he's, what, 29, you said?
Yeah.
I'm joking. So, a very senior gentleman, one from Talend, one from Databricks, trying to just, help solve some data problems which everybody faces, basically. So the intent is to help you talk about the latest, what's happening, how do we address some of the common problems, what does serverless mean, how does Talend help you, what does Databricks does. We go through some introductions, and then we go through some problem statement, which we'll try to, say, describe the approach and how we solve it. But, my wish is, my hope is you take something back, you learn something new today, and you want to make sure this team keeps growing. If you have any feedbacks, or if you have what you do, if there's something you want to hear next about, please let us know. The people to reach out is Laura here. She runs Talent Community, and Drew back there. Reach out to both of them if you have any feedback, if you want to know what we want to do next. Other logistical items, I think the washroom is out on the left.
Another logistics, because really we live and die by this whatever you online. Just jump down in here for any topic. It doesn't have to be about knowledge. Here, and by the way, if you're in, if you're a rock, and you have price, not prices. So, calibrate for the speakers to calibrate the presentation are if anybody here at Talend, customer or
Any Talend users, open source, enterprise, doesn't matter, just okay. Any Databricks users here? Any big data users in the hall? Okay. Anybody to do anything with data engineering generally? Okay. Couple of them. Okay. Good. Is that good enough information? Okay. Thank
How
you,
many
guys.
data scientists?
Any data scientists in the room? Junior. Okay. That works? Yeah, that works. Absolutely works. Okay. I hope everybody gets something out of it. We'll be here if you want to talk to anyone of us. Sure. Thank you for coming out. I'll hand it over to Prasad and Robert.
Greetings and salutations. Is this being recorded now? Is this good? Coming in live? Hot? All right. So hello and welcome all. I'm Robert Morris. I've been with Talend for 10 years, but who's counting? And I certainly haven't learned everything yet, but I do welcome a lot of questions. We are proud and pleased to have Databricks joining us tonight to talk about serverless, managed data scientists, machine learning, and how we do that as a co-solution. So now my co-presenter, Prasad, welcome.
Thanks, Robert. I'm Prasad Kona. I'm a solutions architect with Databricks. I mean, I've been in the industry for close to 20 years, working on data integration, big data, and using various tools to simplify and make sure that customers are successful as they implement big data solutions. So
Next.
all right, let's. So yeah, so companies have been trying to adopt AI and machine learning in order to. So, do we have a mic here?
I have to use both.
I guess so. Hello? Okay. All right. Companies are trying to adopt machine learning and AI so that they can actually foster the next round of innovation. And and be able to beat out the competition. I mean, they have lot of surveys and white papers that have been released, and one such one is what you're seeing on the screen here from Keystone Research, which according to which they say that if you're looking at the top quartile of companies who have invested in technologies relating to uh, 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 an efficient and unified data platform and cloud-based technologies, they were able to more than outperform the bottom two quartiles, and they have been able to not only double their operating margin, but were able to but were able to innovate faster and also increase customer satisfaction. And so what are some of the things that happens about, or what are needed in order to implement some of them, go towards making sure the adoption of AI, right? And this is based on a white paper released by Google that kind of illustrates some of the various things that need to be done in order to reach a point where you can actually uh, be able to successfully utilize or get benefit out of AI. If you look at this, most of the things that you're actually doing outside of the actual focus on machine learning and AI is things about how do I ingest the data from various sources? How do I do the data prep? How do I do the feature extraction? And so this is all data engineering. And so the hardest part of AI is how you deal with and manage your data. And if you look at many of these boxes, and so this is, think of it as this is one side of the half of all the areas that you see on the screen. The second half is about the infrastructure and management and monitoring of these monitoring that you need to do in order to be successful. And so you need to have some kind of a scalable infrastructure that needs to be managed. You would need to monitor your data pipelines. You're having this on the screen. Oh, okay. And if you see just the green box in the middle is the amount of effort and the footprint of what your actual ML and AI code is, right? Most of the time you have a cycle in which you do it after you have ingested or got your data from these various sources, you're doing the feature extraction, you go through this entire iteration of the life cycle for machine learning, which we'll go through more detail later. But this is from this white paper, and I think this is very much true. Right, Robert, have you seen this when you're dealing with some of your customers?
Oh, absolutely. Our entire goal is to make you spend more time and more money on the green box and grow it larger than everything else. So that's where a partner such as yourself that takes care of a lot of the stuff across the spectrum really is a synergy with what Talend brings to the table too.
Yeah, and so if you look at as you've seen here on the screen, like most of the things that we're talking about is about data engineering, right? And that's where Talend would fit in to be able to fill some of the skills gap that we see at various companies. So let's just do a.
Okay.
And so at Databricks, our vision is to have create the unified analytics platform where for data engineering, machine learning, and AI, on which you can have whether it is data engineers, data scientists, or business can collaborate together on this platform. And that was our vision by which we have created the Databricks Unified Analytics Platform. This is based on Apache Spark. Databricks was founded about 6 years ago by the original creators of Spark. Even now, we contribute more than 75% of the code to open source Spark. We have also done a number of innovations as part of our unified analytics platform, namely Delta MLflow. Um, this is a completely managed service that is available on AWS and Azure. We are cloud agnostic, and so whether you have your data either on S3 or on Azure Blob or ADLS, you'd be able to use the unified analytics platform. We have more than 2,000 plus global customers who are currently live on production, doing data engineering, machine learning, and AI. And so, all right. So, so what does it take, or what are companies doing in order to use AI? Right, you have lots of data sources that various companies, whether it is in the financial sector, you might have information about various transaction data, customer data. You have data from CRM and HR systems, and the opportunity here is to create some kind of a fraud detection model or a customer 360 model. Whereas if you look at the healthcare sector, you have data from whether it is health claims data to genomics. People have been collecting and putting into the data lakes, and the opportunity here has been to use AI and machine learning to do whether it is the sequencing of genomes, be able to reduce costs with respect to claim processing. You also have a lot of IoT data and others, right? And with all of these various data sources, one of the things that comes into picture is the three or four personas that are required, right? In order to do this, you have a data engineer whose main job is to be able to ingest data from all of these various sources and for analysis. They need to work very closely with the business because they know they are the SMEs on what data they require. On top of that, you need a data scientist who has particular skills that are required in order to do machine learning on top of this data. And this is not a one-time deal where you're actually, once you've ingested your data, you're done, right? It is actually an iteration, and all the three personas would have to actually work together very closely in order to be able to get data ready for analytics.
Sorry.
All right, okay. And so let's see about some of the challenges that we have seen while companies are trying to adopt or do some innovation on AI. Right. One of the main thing that that everybody requires is a big data platform. Right. I think it's when you're having large data volumes, you have various technologies that are involved. You have complex infrastructure that needs to be set up and maintained. And depending on your data volumes, you might have to expand. Say, for example, if you're having an on-prem big data cluster, it might not be sufficient to do some large workloads. You would have to work with infrastructure to be able to scale that out. And not only that, to be able to operationalize and to be able to run your jobs in a performant manner, one would need to have multiple iterations with your operation teams. The second problem is about data, right? I think it's over a period of time, many of you might already be familiar with Lambda architecture. You have data that is you have batch and streaming data, right? And especially when and how do you deal with backflows? And so all of this results in things like stale data to also create pipelines and processes in order to make sure your data is pristine, right? And so people have been facing issues on how to make sure that the data that they have collected is is they're collecting the data correctly and that the data is reliable. On top of this, we also have various types of frameworks that are available for analytics and machine learning, right? I mean, you have from Hive, SQL, Spark, and other engines, and for machine learning, I mean, you have a ton of frameworks because yeah, with respect to machine learning, you need support to various algorithms, frameworks, and some of these frameworks require specific infrastructure and specific setup that needs to be done, which is again very hard to set up. I mean, there are certain frameworks that work with only that needs to be optimized for certain CPUs or GPUs, right? And the setting up these infrastructure and making sure that they're operationalized is a huge challenge. So once, say, we have solved all of these, what next, right? We have a number of personas, right? Whether it is, we talked about a data engineer who might be using a certain set of tools. They might be using Python, Scala, or Java. And you have some data engineers who are more familiar with the visual drag and drop tools, who want to use a slightly lower code approach, right? The second set of personas that we talked about earlier, the data scientists or analysts who use SQL, R, and other languages. And you have the business folks who might use SQL and some visualization tools, right? In order to, there is a lack of collaboration or a single tool that one could use across all of these personas. And so these are some of the challenges that are slowing up adoption of AI. And so, in order to solve some of these, some of the things that we just talked about, Databricks unified platform helps you with addressing many of these concerns. At the bottom, we have it's a fully managed service. That is, it's a first-party service on Azure, and so you could go to an Azure portal and be able to subscribe to Databricks. If you're on AWS, you can go to the marketplace and start a subscription of Databricks. What this gives you is an ability for you. It's a fully managed platform for a scalable managed clusters, and so you would not have to deal with anything with respect to operationalization, operations, or setting up your clusters. It's all just a click of a button or a call of an API that would spin up a cluster that can scale. And so during the demo, I'm going to show you how even a cluster can scale by depending on the amount of volume or depending on the data that you're actually processing. The clusters can automatically scale. As part of the platform, it is completely integrated with security, and whether it is if you're using Azure, for example, it is you can use single sign-on and Azure Active Directory, similar on AWS also. On top of this, the base platform will be what we refer to as the Databricks runtime. Databricks runtime is a highly optimized version of Spark. And so I know those of you who have used open source Spark are familiar that Spark is extremely fast, and you can process large amounts of data much faster than many of the other frameworks, right? With respect to the Databricks runtime, we have actually enhanced that and optimized whether it is connectors and Spark to be able to perform between 10 to 100 times faster than open source Spark. We have also prepackaged various machine learning frameworks that are required for data scientists as part of the platform. And so now you do not have to, if you want to switch from one framework to the other, you don't have to work with a ton of people and assign resources in order to be able to set these up. All of this is prepackaged as part of the Databricks runtime. And to solve with the problem of collaboration, we have an interactive workspace where data engineers data scientists and business analysts can collaborate together on a single notebook. If you're familiar with Jupyter notebooks, it is very similar to that, where we have enhanced that to be able to support multiple languages. And so you can have a single notebook where you can switch between multiple languages. If you could use either SQL, Python, R, or Scala, all within the same notebook, within the same context. And I'm going to show as part of the demo on how you would be able to do that. So as part of the runtime, we also have a couple of frameworks I mentioned that were there on the previous slide, right? Delta and MLflow. I'll talk about a little bit on these two particular frameworks. So over a period of time, when various companies are working on getting data from various sources, right? They've been collecting data, putting it onto to their data lakes. The data lake can either be on say, for example, if it is AWS, on S3, if it is on Azure, it's on Blob or ADLS, right? With Databricks Delta, what we have done is we have made we have provided reliability to your data lakes, and so it sits on top of your data lake. And what we provide is we provide asset compliance to your data. This happened. Yeah, let's just click on present, and I guess on the top. And so by providing asset transaction capability, you're making it more reliable. And so whether you're trying to put in a few records or billions of records at the same time, we provide a transaction capability for the entire for the entire transaction. And so if a particular if you're ingesting data for every hour, for example, if a particular hour, if there is a failure, you would be able to it will automatically roll back and gives you an opportunity to be able to fix your data, reprocess it, and send and then ingest it. We also enforce schema. This ensures that your data conforms to the schema and you have data that is of a much higher quality. So the way we do, we also collect a lot of metadata while we are actually capturing this data. This provides us an ability for us to, say, travel back in time, and we call this feature as time travel, where you can actually run a query as on data that existed at a particular instant of time. We are not talking about a small data. Whether you have a petabyte of data, you should be able to run a query on data how it existed as of at a particular timestamp. Say I'm interested in looking at my data from 1 week ago. I can run the exact same SQL query or your machine learning model, and it would use the data at that particular instant of time. The way we do this is because we used versioning of Parquet files behind the scenes, and also maintain a transaction log. And so some of the things that we have done as part of the Delta enables us to do the travel back in time. In addition to this, I think this also, using a Delta table, you could also support batch and streaming data. You'd be able to run your analytics on your entire data set. Previously, for example, you could potentially run your some kind of an analysis on just streaming or on batch. But the power of Delta is that you'd be able to run your analytics on your entire data set. And be able to get a very fast response. We also have indexes, and all of this helps in scaling your data in Delta tables. Say, for example, Apple has Delta tables that are multi-petabyte in size. They run their analytics on top of that for threat detection. So we talked about some of the complexity involved in for a machine learning lifecycle, right? And so let me just do a quick steps on what happens during our life cycle for machine learning, right? So once you have, the first thing it starts with is you need to be able to ingest data from various sources, right? And as you've seen on the slide from Google, a lot of effort is actually spent in data prep. And once that's an iterative life cycle that happens, and then you start building the model. And as part of the data scientist would be creating models. They need to be running some experiments, trying to optimize the algorithms, maybe switch to different algorithms or different frameworks that need to be used, right? Once you have done that, they need to be able to deploy these models. So deployment is not the end state for a data scientist. That's just a starting, because once you deploy a model, there might be new features that impacts the model. There might be new data that actually changes this. And so there would need to be a cycle in which they would need to do continuous improvements on that. And so at a very high level, that would be the life cycle for machine learning, right? And so with respect to ML flow, we help you operationalize the machine learning life cycle. Whether you're how to track experiments, how to collect data to be able to see what the accuracy of some of your models are, to be able to use to be able to deploy models, to be able to actually integrate with say, for example, if you're on AWS and you're using SageMaker, be able to deploy models to that, or to Azure ML. And so all of this is included as part of ML flow. So maybe I'll take a pause for any questions in the room before we continue. Just want to keep this this interactive.
Well, somebody has a question, don't they? Thank you for that reminder. All right.
Yeah. Well, absolutely.
Okay.
All right. And so I think it's now we are going to show about how we can actually, like, how Talend and Databricks will be able to speed up your implementation of help for AI and machine learning. And so, Robert, do you want to talk about Talend? Yes.
Regarding the machine learning, I'm not professional in that area, but since you use some tools available, I'm just start using the Python.
Yes.
What is the difference between when I'm using something scratch like Python or R, or for example, something like the application you show that in a like a presentation? What is the difference? For example, I'm looking for the data frames for retail users. To read like the sales system, like to look to the sales system for a product. I'm trying to understand exactly, to learn about like the consumer behavior. And what is your suggestion when we go to analyze data? We should go, for example, from something that you demonstrate here, or no? We should go start from scratch, something with the Python or. And
so that's an interesting question. And so I think it's just to rephrase that, two aspects to your question, right? The first one is how do we start with what kind of tools we use, whether it is in order to do machine learning, or the first part is to how do you get your data, how to do data prep. And we are going to show how, for example, if you want to do in a visual manner to be able to create some of these, to ingest the data, to be able to do some data prep. We're going to show that as part of this demonstration. The second aspect is whether to continue using Python for certain machine learning. Yes, Python, whether you're using Python, R, or any other SQL, those are will continue to be your tools, and they would be some things that you would continue to use even in notebooks within Databricks. Yeah, so it would be a combination of both of these tools that you require in order to be able to effectively do machine learning and be able to operate.
What is the benefit, for example, if I'm start using your product? Well, it's help us, it's improve, it's speed up, there's more benefit.
And so hold on to your question for a couple of minutes, and I think it's hopefully we'll be able to answer that.
So machine learning is coming, if it isn't already, in your organization. And what Talend is proposing is a collaborative solution and a complementary solution, right? We can help you get the data from all your disparate systems and get them into a storage area, into a data lake where you can start using machine learning. But the other advantage is so that you save time and money on not hiring the expensive people to build and maintain your clusters and stuff. This being a managed solution means I save money on infrastructure and I save money on headcount and salaries and all that kind of stuff. So that's why we're proposing this solution. And it's a complementary solution in that if you start stuff in Python or any other, language or algorithm, then you can reuse that stuff, but incorporate it as part of a bigger process. So we don't advocate going, any way at the beginning. It doesn't matter. We want to add to what you have or what you started with. Does that make sense? Okay. So anyway, enter Talend. This is a Talend users group. I don't really need to tell you guys a lot of this stuff, but, I feel that with the number there, 900 plus components and connectors, that's kind of old. We're up to 1,000 different files, tables, web services, message queues, SaaS apps, everything that you can pull data from. We gather that data from wherever you store it, right? We also can process it. We can also govern it. We also have data quality built into every one of our solutions. We also have an ability to catalog data, to cleanse, to profile, all that kind of stuff. So data governance is baked in to every product that we manufacture. We're also the first to market for Spark and actually kind of first to market for big data. So, we not only do we build in Spark libraries into our software, into our runtimes, we basically code generate Spark tasks to be ran on a Databricks cluster, and Databricks is one of the pull downs for where you're going to deploy this particular code. So, we're also becoming more or less of a SaaS company ourselves with our Talend Cloud offering. So we're going to leverage the savings of infrastructure and of headcount and talent. So by managing hosting our service for you just to consume as a service. And then finally, we've always been this way. We price only by how many people have a studio on their laptop. It's no CPU tax, no charges according to how many records you process or anything like that. So it's simple and predictable and has always been disruptive. So that's pretty much Talend and why Talend in a nutshell. All right, so you want to talk about Databricks real quick, what we're bringing?
So just what we're going to show, oh yeah, we need to be close to this one. And so with Databricks, now you have a platform where you can actually scale your data pipelines, whether you're doing data engineering or machine learning, to be able to run them at scale on a fully managed clusters as I mentioned earlier, the Databricks Spark is about 10 to 100 times faster than open source Spark. And because these clusters are scalable depending on the data volumes that you're executing, you would be able to reduce the total cost of ownership. You do not have to run your clusters at 24/7 as you do with your on-prem clusters. You can just spin up or run a particular job. As part of the job, the cluster spins up, it automatically scales to handle your data volumes, and it shuts itself down. You can also have clusters that always are running if required, but And so these are ways in which you can reduce the costs that are involved. So do you want to talk about talent?
Okay, so as kind of a co-solution in this event, basically you're using Talend a lot on the front end to extract data from all those disparate systems, put them into the data lake environment. So we're going to help with the ingestion and the prep and the cleanliness of that, so you can trust the data, use the data, etc. We actually tout like a 75% productivity gain over hand coding using our visual drag and drop studio. And we are a Talend, we're Talend, it's a Java code generator, right? You don't have to know Java. It just helps you generate tens of thousands of lines in 30 seconds. I don't know Java to save my life. I can't even spell it. And I can generate 30,000 lines of working code in 5 minutes. So, not everybody knows these advanced languages and algorithms like Scala, R, Python, etc. Talend can usually handle something similar to those languages, and you just use a visual drag and drop studio, which we will demo later on tonight. And, we're just hoping this can make you more productive and spend more time making that red or that green box in the middle, spending time on your machine learning code instead of the infrastructure, the ingestion, the data prep, and all that kind of stuff. So we're making you, hopefully, proposing a solution to help you spend your time more wisely. That's it. Okay. Was this you?
Yeah, I think it's here. It's just summarizing what we just said.
Okay.
Let's go to the next slide. So,
I can talk about this.
yeah, sure.
All right, so we have a co-customer, Uniper, an energy company in Europe, who has deployed both of our solutions together synergistically. So what happens is, you can read the quote. They do things cheaper, they do them faster, and they actually gain synergies where the whole is greater than the sum of the parts by using these two solutions. Basically, what they were trying to do is they trade energy, a lot, and with many different vendors. They're a vendor themselves, and they really wanted to reduce the analytics and the predictive ability around the price, the quantity, the volume, and stuff like that, and kind of look at more of a decentralized model. So with Talend and Databricks, they did achieve this. Any questions about Uniper? I know we didn't cover it very much, but are any questions that we've had about Talend or Databricks? Yes, sir.
So you mentioned the drag and drop interface with Talend, so graphical user interface. One of the advantages of knowing a low-level language like say Java or C is the ability to specify and control small details and algorithms. Does Talend allow you to tweak the graphical GUI for exact specifications, or is it just some of the
So at Talend, we're very extensible in that you can include snippets of your own code. You can actually request an open source copy of the source code itself and maybe tweak it and tune it if you want to. We also have components to pass variables and parameters into other programs, to launch other programs, to monitor and manage them or incorporate them as part of the Talend flow. So I agree that with hand coding, you do have tremendous control. But instead of doing one or the other, I guess Talend would be a proponent of using both.
Yeah, and I think it's just to add to that, right? There are two aspects to this. I mean, we have different personas who want to be doing different things, and we are also trying to bridge a skills gap at certain companies. So there are a couple of different personas that are there. One is data engineers, right, who want to do who have technical skills to be able to code. But there is, if you're looking at various companies, there is a huge shortage of that people with that skill, and organizations have been trying to upskill some of their existing engineers to be able to do newer technologies, be able to do things using a drag and drop approach, right? And so, by using Talend, yeah, I need to be close to this. By using Talend, you're able to use a visual drag and drop to be able to bridge that skills gap. Now you have more number of engineers or data engineers at a company who are able to contribute to an initiative. Does that make sense? I mean, we still need some coding. Like, say, for example, if you were like a data scientist, would probably use a little bit more coding to switch from one algorithm to the other, and that's where they would use a notebooking interface in Databricks, for example, to be able to write their code, debug their code, and then execute that code. Operationalizing it, again, is a different step, right? So once the engineer is done, you need to be able to operationalize it. That's where, again, Databricks and Talend comes together with reference architecture.
Any more questions?
And so this is how we see as how one could use Databricks and Talend together. With the rich set of connectors from Talend, you're now able to ingest data from a lot more sources into your data lake, right? And you will be able to ingest this data into Databricks as part of, we'll show as a part of this demo how we do that.
All right. I just want to do some vocabulary stuff. So who in the room can tell me what serverless means? Go for it, Ira.
Basically, easiest example is AWS Lambda, where you're running a function on top of the server, but you're not necessarily deploying some, whole program. You're just deploying a snippet of code.
Mm-hmm. Sounds good. I think, and also what it means is you're not running a server 24/7, paying for the electricity and the maintenance and all that kind of stuff. It basically means my server is transient. It starts when my process begins and it ends when my process ends, right? How about auto scaling? That's pretty self-explanatory, right? And then, so this architecture here, top down, left to right, is kind of where and how each piece of the solution is involved. So just to reiterate, Talend is helping you get at all those applications and all that data, get it to where you need. It really doesn't matter where you're storing it, Azure or Amazon. We're compatible with both versions. And you're typically going to use the Talend Studio as the single design environment for creating those ingestion type jobs and maybe those cleansing type jobs. You schedule them, you monitor them, you manage them in our Talend integration platform as a service using the Talend management console. And then in the Azure or the Amazon interface, that's where you provision your cluster, manage your cluster, and all you need to do is tell Talend where that cluster is with 3 simple parameters, and then you're off to the races. It starts when the process is deployed. It ends when the process is done. If it doesn't finish, then you have some automatic shutdown parameters to save you money and stuff like that. But the point is, we are trying to give you the ability to, like you said, hand code your own kind of stuff for ninja type applications. And then for the casual user or the business user or whatever, then they have an interface that they can use. We're just trying to cater to all the different personas involved in a machine learning project and kind of give them a collaborative solution to, you know, synergistically build whatever they need to do. Good. So just wanted, okay. So the question is, are the connectors part of the management console? No, not really. So inside of your design studio is a palette. I will show you that in a moment, where we have drawers and you open them up and you pull out stuff for Redshift or JDBC or Kafka queues or whatever. So the connectors are the components that are the sources and the targets and the transformations in the ETL. The management console, once that compiled jar file has been manufactured, the management console is where you deploy it, you monitor it, you manage it, stuff like that. So Studio and connectors, design, and management console is really operations.
So once you have actually used the yeah, I'm just connect this to this guy.
There you go.
That might make sense.
Nice.
All right, that's better, huh?
I like that.
Yeah. And so once you have got your data using these connectors into your data into Databricks, right? You can use the Talend Studio in order to create jobs in which for data engineering that can actually run at scale on the cluster. Just like using the same drag and drop approach, you'd be able to get data, do transformation, do data prep on it, and this runs as a Spark job on the Databricks cluster. And so by that, you're able to use a managed scalable cluster that runs on Databricks.
You want me to explain the demo?
Sure, you can start. Yeah.
All right, so tonight we're finally getting to the meat and potatoes of the meetup, the actual demo itself. Sorry for the lengthy PowerPoint, but we just wanted to kind of establish a baseline of what we're about to show. So we have a bank, a financial institution use case. People are using cards like credit cards, ATM, debit cards, etc. And we want to capture you know, any fraudulent cases. And while people are using their products, we want to kind of capture their usage, the behaviors, some information about, you know, their persona, so that we might be able to offer some future solutions and other stuff like that.
And so I think it's this is just, I think, part of a lot of what financial companies are doing, right?
Mm-hmm.
One is they want to do a 360 customer view of the customer view, and be able to reduce their liability by doing fraud detection at scale on various transactions. So
I can actually speak personally about that, because I've had to change my credit card twice due to fraudulent, you know, behavior and stuff like that. And I'm always amazed that, you know, they can notify me via text or a phone or an email that it's happening, and I'm not even aware. So then when I call in, they ask me, what are your last 3 transactions? Oh, does that belong to you? I say no. I'm like, darn it, I got to change all my credit cards where I pay stuff everywhere. So this is kind of the situation that we're talking about here. The, you know, the executives are very interested in this because, you know, they want to make money off of their data somehow, and they want to reduce risk, and they also want to improve, you know, customer satisfaction. Because I'm happy because Wells Fargo caught those, you know, before they really snowballed into something that was amazing. And, you know, some of the limitations and constraints that we have, maybe many companies share this, is, you know, there isn't a lot of well-trained, highly practiced Spark professionals or big data professionals out there. If there are, then they are, you know, at least $200,000–300,000 a piece. So we want to reduce, we want to empower people and maybe give them some access and some controls and some capabilities beyond what their real current skill set is. Another one is, you know, if you own and operate your own cluster, that's kind of an expensive kind of proposition. So we're trying to help people save time and money on, like we said, the operational costs, the personnel costs, et cetera. And then, you know, it takes a long time to procure hardware and software and put it all together and make it work. We're trying to shorten the life cycle of that and make it as easy as 6 months.
Yeah, and I think it's just to add to that, I think in this particular scenario, you want to show where this particular financial services company is also having issues with respect to from where they're getting data. They're getting data from various transactions and those from various sources. And some of these, like their data warehouse is hitting their capacity, and which is because it is hitting their capacity and it is highly expensive. I think this is something that we have always seen in our data life at every company, right? And because of that, I think the data engineering team have started offloading some of their data to cheap archival storage. And so all of this actually causes issues when you want to do analytics, because now you have data, some data in your data warehouse, some is in some storage in your data lake. In addition to that, you have a lot of on-prem systems. Say, you know, in this case, they have products and locations are on multiple databases that could be on-prem. They use systems like cloud-based systems like Salesforce, for example, to store CRM data, right? And how can we utilize this information about the various transactions and that are coming from the payment systems and be able to create a fraud detection and analysis system? And so that's the main theme of how for this demo. And so this would be a proposed architecture on how we would be able to do that. And so using Talend and its the rich set of connectors, one should be able to get data from these various payment networks and the data warehouses and the various databases, but or it could even be files, FTP, and cloud-based systems. All of this data can now be efficiently ingested into a cloud-based system like Databricks. Once you have your data, you can again use Talend to use a drag and drop interface where you can do data engineering at scale and push down the Spark jobs to be run on scalable clusters on Databricks. Yeah, and the last point about in order to do your machine learning, you would switch to using do that on a Databricks notebook and then be able to operationalize it from within Talend. Good. Yeah. So now let's go over the demo.
Oops. We didn't want you to see that. Unremember it. I'll take over.
Yeah. So Robert, do you want to explain what we see on the Talend Studio here?
Sure. So let me maximize it here. So first, let me ask, who has a Talend Studio involved or installed on their laptop? All right, that's not bad. So does anybody want me to go kind of through a tour of the usage and the main components of a studio? Yes or no? Okay, so enter the Talend Studio. This is an Eclipse application that we've kind of put a bunch of plugins in so that it can be the single design interface for all of our products. Our product mix is pretty vast. We have data integration, data quality, data prep, data stewardship, pipeline designer, data catalog, all that kind of stuff. So just by clicking these different perspectives up here, you can perform the different data disciplines all in a single design interface. Plus, to install the solution, at least on-prem, it's a single installer, right? So everything's kind of included. We're not kind of a Frankenstein by acquisition type of solution. We're all kind of homegrown. I like to describe it as a family, right? We all have the same genetic base, but there are some specialities that each of the children or family members have. So it really all starts with our metadata repository over on the left. And that's where you store, where are all my connections to my metadata, my files, my tables, my web services, my Salesforce, my snowflakes, blah, blah, blah. So you go in and you configure the connectivity, like your username, password, all that, where the host resides. And then that is a persistent object that you can just drag and drop onto the other main place, the canvas. So this is the workspace where everything really happens. You drag and drop different components for connectivity and for orchestration and for file management and all that stuff from our palette here. And it's completely searchable. But once you get to know it, you'll kind of get to know where the components are and what drawer and what category and stuff like that. Alternatively, you can just click onto the workspace and start typing things, and the component menu will let you select from something that's there. So it's all meant to be pretty, easy and productive. And then finally down here, each individual component or subjob or whatever, this is where you set the properties of it. And in the run tab, that's where you run it, and you can kind of watch the logging and the messaging that occurs. So any questions about the studio? And who's going to install one tomorrow? So just so you know, Talend has kind of an open source policy where we have a community edition that's free to download on talend.com's website. And then that is a single user license. It pretty much has a lot of the components and connectors and everything. But what it doesn't do is like monitoring, management, scheduling, and all that kind of stuff. We can and will have people that use that exclusively for years, but usually they'll run into some kind of a situation where they need a certain feature that goes into our subscription products. All right, so about the demo, those use cases and stuff that we described, oops. All right, I have a hard time seeing this with my almost 50-year-old eyes, but the thing about Talend, right, I like to kind of describe it as a bunch of Lego blocks. So we want to build the atomic level stuff first and then kind of orchestrate it together. And that's what you see us doing here. Each of these little icons is actually a sub job. If you click on it, you can go in and view its design individually. We're just using this to kind of cascade a bunch of events. We start up at the top right and usually flow down to the bottom left. First, we're going to extract transactions and stuff like that from point of sale systems. That's the top icon here. Then we're going to synchronize some of our transactions and stuff with Salesforce, and we're going to put that on the Databricks file system as an independent resource. So there's 2 ingestion steps right there. Then what we're doing is enriching and transforming that data. So Talend is now kind of doing the data prep, and it is doing lookups and joins and aggregations and stuff like that completely through using the components. And then finally, that was cleanse and aggregate there. And then what we're going to do is we're going to build the actual fraud detection model. And Prasad's probably much more versed in this than I am, but you basically create a model and you feed it some initial data and you train it up. And that's kind of where the ML, machine learning, it learns.
So Robert,
Yeah.
you want to just show how you do one of the aggregation is like a big data job?
Sure.
In Talend.
All right. So here is a focus on the big data job. All right. So it's annotated here, so you can read along as we go. But you basically start with a connection. Where is your source? Where is your target? We're using ADLS as our storage mechanism. We pull out our transactions from Salesforce or the CRM, and we replicate that into two different flows. The top flow, we are filtering and aggregating and grouping by certain fields that you can see over, oops, I love Max. Hit my holy back button. All right. So here are kind of the fields and the aggregations and stuff that we're performing. So completely by selecting a value or a pull down in a component, you can do min, max, average, sum, list, all that kind of stuff. And then you can group it by any number of fields that you want. And then we're writing that into storage. And then down here, this is probably the most powerful and most commonly used component in Talend. And it looks like spaghetti. So I call it the spaghetti component. On the left, you have your inputs. On the right, you have your outputs. And you have the ability in the middle to do variables, expressions, transformations, etc. And then
So you're able to do all of this without having to write any code in a visual manner. I think that's pretty powerful.
if you wanted to, you could write this. So to kind of build on your question, I like to say if you have one person who's comfortable and cozy with Java, they can use the extensibility features and make reusable objects like joblets and reference projects and reusable code in the code repository. And then the casual user just drags and drops that and takes advantage of it. So we are kind of contributing to both personas. So anyway, here's another neat thing. So we can actually extract fields based on XML, XQuery, JSON, any other type of pattern and stuff like that. We also have masking. So if we want to kind of confidentialize and obfuscate certain fields from prying eyes, so we don't have GDPR or CCPA issues and the regulators breathing down our necks, we can use a component like T-data masking. All right, so this is basically kind of we're code generating a Spark job in the background, and this is what gets executed on whatever cluster that we have provisioned inside of Databricks. Do you have anything to add?
Yeah, I think it's, maybe we can just show how simplified they are made with respect to how we can run this job on a cluster.
Okay. Run tab.
Run tab.
Spark config. There you go.
And so let me just maximize this one. So if you look at this connection now, it's completely simplified. Or there are just a couple of fields that you need to be specifying with respect to access and with respect to the Databricks URL. Just select the type of cluster. You'd be able to say you'll be able to select the version and a couple of other properties, like say with respect to scalability, or select the instance types. Once that is done, the cluster is going to be spun up automatically when this job is submitted, and it will be turned off after the job is completed. And so in this way, you're making sure that you're not wasting resources. It's a completely managed, scalable cluster that is operationalized for this particular job.
Do you want to show them some of the diagrams and end effect? And we'll get into
So once you just hit on run, this is a job I just ran a couple of minutes ago, and you can just see that it is it basically starts the cluster. Once the cluster is ready, it runs a job on the Databricks cluster. I'm going to walk through on the Databricks side. We can see the job being submitted and executed. So you can actually see the various jars and the libraries that are used for this job. And so these are all uploaded onto Databricks and then executed. Any questions before I switch to the Databricks side of the demo?
I'm getting already the talent regarding that moving data from source registration
Mhm.
to manipulate data. But I don't understand exactly the data. With each part of product should be what.
And so, as you see, right, the amount of configuration that you need to do in order to run this as a Spark job is just what you see on the screen. Just some of the credentials and what version of Spark that you're going to be using on Databricks. That's it. Talend takes care of submitting the job correctly on the Databricks cluster, and the job will run in scale, whether you're running on a few gigabytes of data or petabytes of data. It would run on Databricks.
There is a more component for product talent.
They would submit the job onto a Databricks cluster, and that's where the whole processing happens. Then, so the Databricks is the entire unified analytics platform that would be supporting this data engineering job that is being submitted from the Talend UI.
That help? We're the design, they're the execution and the machine learning and all the, I guess, visualization too, and operations.
Yeah.
Is there a way to execute the analytics of Databricks?
Yes.
I mean, it's if you need to be able to execute it. If you're having a large data set, you need to execute it on a scalable platform that involves like Spark, right? And Databricks is one of the options that is available from Talend.
Does your company own and operate a Spark cluster? Does your company own and operate a Spark cluster? Okay.
Okay. Yeah, and so especially if you're using Databricks, you don't have to maintain your own infrastructure and manage them. And so these are completely managed clusters that are more performant. And so that's where customers have actually seen that their total cost of ownership going down. Mm-hmm. Yeah. Okay. And so this is a play here, right? I mean, if you're looking at how Talend adds value, it is trying to look at that. When we talk about data engineers, there are two sets of people who actually write, who are able to, or who write code, whether it is Python, Scala. They could potentially use a notebook where they can do their data engineering or submit a job, write it in Java or pass Spark SQL and execute it on a cluster. Yes, one could absolutely do that. And so with Talend integration, now we are actually able to increase the number of people who can actually take the role of a data engineer, because not everybody is that familiar with actually coding. And so now you're actually be able to do to have even slightly less skill on existing folks at a company to be able to run data engineering at scale without having to write any in any other language. And so that's where Talend comes in. And it also has a rich set of connectors to get data from various sources.
That help?
All right, now let's switch to Databricks. And so for the purpose of this demo, I'm actually going to be using Azure Databricks. And so if you are working on AWS, it's going to be exact same thing. I mean, the functionality on both environments is on par. So once you log in, what you're going to see is this is the homepage for the main home screen on Databricks. There are some links on whether it is documents or common tasks that you need to do. I'm going to start off with the job. I think when we ran the particular job from within Talend, you can actually see that job was kicked off on the cluster on Databricks. So this is the jobs UI where you can actually keep track and manage all your jobs. So it as part of this final pipeline that was job. I mean, there were a couple of jobs that were submitted by Talend, and
It's your tab.
which one is the last one? Yeah, this is the fraud model. The last step is actually, I just want to show this one before we actually go into the Databricks demo, because this is the last step on this particular flow. We have ingested the data, we have done some transformation and data prep, and finally, the last step is to build and score the model, right? And so this particular pipeline is basically doing a REST call to be able to and it calls a Databricks notebook, and that's where the machine learning model has been created. And the second one is, like, say, for example, how do you operationalize this? Once you've built your model and it's deployed, you're getting data streaming in, and now you need to be able to predict, like, say, in this case, fraudulent transactions using that particular model. That is the second part of the one, which is where basically we are scoring based on that model and creating a subset of the fraudulent transactions. And so when this particular job was executed, that resulted in these jobs. Let's just click on the machine learning model. You can actually see the various runs that were executed. And if you're familiar with Spark, it's the same UI. If you can look at the various Spark job that was submitted, you should be able to drill down and debug any job, if you're familiar with Spark. But it's a single one place where you can see you have access to all the logs. And for each run, you can also click on a run and be able to look at the actual notebook. I'm going to review this notebook, but you can actually see the execution and output for that particular run. All of this is available on the Databricks side. And so as part of a job, you also have various configuration parameters where you can, like, say, what notebook has been used, what dependent libraries. You can actually add your own dependent libraries also. And I'm going to show you how Talend jobs have been added as libraries. You can also, within Databricks, you can also, say, for example, run this particular job as a schedule. We have APIs that are exposed so that you can call it from your scheduling tools. And also, I think earlier in the previous Talend job, you have seen how from within Talend, you're able to call the Databricks jobs API behind the scenes to be able to submit the job to Databricks. So a couple of interesting things that I would just want to point out here is, say, for example, you can specify a cluster that, in this case, for this particular job, I just selected a cluster that is already running. Or you can actually select a cluster that is actually spun up to run this job. In this case, this is a ephemeral cluster that you're given the size or how it's going to scale. Let me just click on edit. And so it's going to bring up a new cluster with a certain configuration and be able to scale. When you're so you can, let me show you the clusters UI next, where when you create a cluster, you'd be able to select the type of clusters. So there are two types of clusters that are available, that are standard and high concurrency. And so a standard cluster is what you're going to be using in terms of when you're running a single job or when you're running your things that are done at a particular schedule, right? Or even a Spark streaming job, you could run it on a standard mode cluster. So a high concurrency cluster is used more for BI application where you want to be running a cluster throughout the time. I mean, just like you're on-prem, you are running a cluster for an extended period of time. You have hundreds of concurrent users that could potentially connect to the Databricks cluster to be able to extract data or submit jobs. And so that's when you would use a high concurrency cluster. You have various, you can select the runtime. And so yeah, the runtime comes with, if you use a ML runtime, it would have all the machine learning packages already pre-configured and available as part of Databricks. You can also select the version of Python if you want to use. And one of the most interesting thing is about autoscaling. Autoscaling enables you to scale based on the load. If Databricks, if a particular job is running on Databricks and we see certain tasks are queuing up on Spark, we would automatically scale your cluster by adding additional nodes. This is really powerful because now you don't have to, your job is not going to fail and you don't have to rerun your job. The cluster automatically scales to be able to support your job. And so this is the power of Databricks there. And in order to reduce costs, you can also set up something to terminate a cluster if it is not active, whether it is a high concurrency cluster or for a regular cluster. You would be able to make sure that put some kind of an inactivity timeout so that if a cluster is not used for a certain period of time, to automatically shut it down. You can also select the size of the nodes in the cluster, the minimum and the maximum size in which the cluster can grow. Say, for example, if you were to use AWS, you will also be able to see to use spot instances. By using spot instances, you can also reduce your costs even further. I mean, now you have scalable clusters that increases that adds nodes depending on your data volumes, and you also are able to utilize things like spot instances to reduce the cost. And you have Spark, the Databricks runtime, and its optimized version of Spark, which is 10 to 100x powerful. And so all of these in combination will ensure that your total cost of ownership is very, very low. So this was one of the clusters that we have used. And so you can click on the advanced options, and there are some interesting things that are here. If you want to pass certain configurations, normally the way we have actually optimized Spark for performance, right? When you use open source Spark on an on-prem cluster, there are a lot of things that you need to tweak for a particular job. Here, with respect to Databricks, you would not have to do all that. It's already been done as part of the platform. And so you would, as you see in the previous, the job submission UI, even in Talend, you saw that it was very simplified. You didn't have a lot of configurations with respect to Spark configurations or how much memory that you need to use and all that. That's taken care of by the Databricks platform. If someone were to use certain libraries or init scripts, all of that can be done also as part of this cluster if you want to install certain packages on top of what Databricks provides. So at a point of time, you can also look at what notebooks are actually connected to this particular cluster or are executing on this cluster. You can click on a libraries tab. So these are all the libraries that were automatically uploaded as part when we actually ran the job. And so these are all the dependencies that Talend has uploaded. And let's have a look at a few things here. I wanted to point out, if you look at these here on the screen, the filtering, aggregation, these are actually the code that was generated by Talend and submitted to the Databricks cluster to be executed.
We don't need to know all that stuff. All that's done automatically for you. You're not worried about every little individual jar file that gets loaded, or if it's broken, or what version you need to use, etc. It's all automated.
Yeah.
Yes.
My understanding, right? This is the data that Talend is pulling out of its vast resources and sending to Databricks.
Not yet. We're more getting into the guts and the details of Databricks and the cluster and the execution environment, and it all looks intimidating and complex to me. It is vastly reduced in complexity and stuff using their solution as opposed to trying to do it yourself.
So this isn't data.
No,
What is this?
And so this is actually like, so once you ran the Talend job, right, it got converted into a Spark job that ran on this cluster. And so you're actually if you're having a really large data set doing multiple joins, you would not be able to do in a smaller infrastructure. You need a bigger cluster, like something like a Spark cluster to process that. And so here, what we have done is just by visually creating that one and submitting it, the execution of the job, the spinning up of the environment, the management of the environment, all of that is taken care of by the Databricks. And so we are showing a little bit on the low-level details of what happens behind the scene on the Databricks side. Earlier, we have seen how easy it is to actually visually create the pipeline and flow. It looks like a regular, almost like a Visio kind of a flow chart where you're doing dragging and dropping these various components, being able to say, hey, I got the data, just get this data from Salesforce or from this particular EDW table, do a join, do some aggregations, all in a visual manner. But it looks very simplistic. But we are now able to run that at scale on an extremely large data set, which would not be possible if we were not using some big data technologies or Spark. Yeah.
So to feather into your question, right, we're looking at fraud. How many fraud instances and stuff have we had? How accurate is our machine learning model at finding and predicting those? So those are some of the diagrams I would like to point out later.
Yeah. And so this is about just the operationalization part of it that I'm first demonstrating, where you're creating the cluster, you're having a single place where you can actually see the access the various logs that are available in order to debug as needed. And so even within Databricks, you can see a couple of, I just want to highlight a couple of these tabs. So you can, this is the data tab where you can actually, whether you're getting data from, you can create tables, you can, how to ingest data from various connectors. These are optimized connectors that are part of the Databricks platform, which have been specially optimized, even whether you're dealing with S3 or dealing with the ADLS or the various components that are on these ecosystems. So as we are looking at Azure Databricks, you can see Azure Blob Storage, ADLS, and some of the Microsoft components. Whereas if you look at Databricks running on AWS, you would be able to see some of the ones like Kinesis and others will be there as connectors in this drop-down list. So you would be able to extract or get this data from these various sources, be able to then ingest them into tables. And so once you have them ingested into tables, like what I've described about Delta earlier, so you'll be able to ingest them into a Delta table, and that's much more powerful. You'd be able to do batch and streaming analytics on top of Delta tables. So now I want to switch to the next tab, which is the workspace. The workspaces are basically the interactive environment where everybody can collaborate together. The data engineers who are familiar with writing code in Python or Scala would be able to use a notebook. These are very similar to the Jupyter notebooks, where so if you have not used a notebook consists of a set of cells in which you can either put from it consists of whether it is documentation or in various languages. And so we support Python, Scala, R, and SQL within the same notebook, within the same context. And so you can actually switch between various languages. We also have some Databricks-related utilities that help you read data or to do some visualization. You can also, it also automatically integrates with various things like Matplotlib or other visualization libraries that you can use within Python as part of the same notebook. And so if you look at this here, right, I mean, as a data scientist, I might start looking at these various tables that were created. I want to do some analysis. I'm doing a select star. This is a cell in which I'm just doing a select star from a particular table. The output of that result, you could actually use for the visualization from Databricks to be able to analyze what's there in the data. The first thing that a data scientist does is they want to look at the data, be able to figure out what are the features that I'm interested in. Because if your data set has thousands of or hundreds of features, it does not make sense to use all of that to do to create a predictive model, right? You would want to use a subset of the fields or data that is attributes that are available in your data to be able to use them as features in your models. And so if you kind of recollect some of that the slide from Google, right? We had that small green box in the middle, which is actually the ML code. Even here, you'd see that what we're going through right now is these actual piece of code, the machine learning code that is actually there, right? Most of the heavy lifting has already been done by now with the data engineering, data prep, masking, transformations, and joining the various data sets in a format that is now ready for machine learning. Now the data scientist is able to just take that, do some feature engineering. He has actually ran some queries, does some analysis on the data, use some visualizations that are available to provide him enough details to be able to build this model. So in this case, he has selected certain features that he is interested in, and in this case, we are using a decision tree classifier to be able to create a decision tree model and to do some prediction. One other thing that is common in order to, when you're doing creating these models, is that you take a sample data and you split it up into some kind of a test and a training data set. And so you use this in order to the first chunk of the data you would actually use to create the model, and then the test one you would actually make sure that is it actually making some good correct predictions. So you'd be able to analyze it and then create your model. And so that's exactly what we are doing here. We have actually split the data into two sets, the training and the test data set. And we have created a couple of steps as part of this pipeline. Ran that particular model. You can see some of the predictions. We can use some evaluators to evaluate how well this is behaving. In this case, for example, it said the accuracy for this particular model is about 0.98, depending on the data that we have used. And so just again, some other tools as part of the notebook, you can also do some visualization on a particular model, because there's a decision tree. You can actually see the details on the for the decision tree on this particular model. So now that this model has been created, I know the second step was about operationalizing. The second one was what we saw was how do you predict it based on the current data set? Like say, for example, we have transactions from the last 1 hour, right? We need to be able to be able to detect fraud for those transactions. And so how does that fit in, right? So that's the second notebook I have. Let me open that. Yeah.
Yes. So I see that you divide the code into certain blocks, right?
Mm-hmm.
So what's the benefit of dividing these certain tasks?
And so in a particular, in a Jupyter notebook or a notebook, what you see here, right? You are able to, just like each node, you can switch from one language to the other. You can all write your entire code in one cell, right? That would make it a little bit harder to debug. You cannot switch between languages. And so if you look here, I had one statement here that's actually doing SQL, and the next one I'm actually doing in Python, and the third statement I'm actually doing a visualization. I could potentially even use R or something like Python, Matplotlib, or some other visualization tool, right? And so the power of having a notebook experience is people are able to collaborate together. So you can actually, as part of the platform, we have ACLs all built in. Say, for example, you have multiple data engineers can actually collaborate on the same notebook. This would be very similar on how you experience what you see on when you have multiple people editing a Google document, right? And so you'd be able to see what the other person is actually updating as part of the same flow. You can add comments and share. I mean, in this particular demo, I don't have any comments on this particular notebook, but you'd be able to see that. You'd be able to see the run history, the revision history, switch back and forth, and be able to collaborate on the same notebook.
Sometimes you use certain like libraries and guides.
Yes. No, it's all of these are running in the same context. And so once you have imported, it's available from then on in the entire notebook. And so in this case, for example, right, I've done an import of a string indexer and vector assembler here. I'm actually using those variables in about a couple of cells down. And so it's you can switch between the context. And so say, for example, if you're familiar with data frames, you could switch between like say like a pandas data frame and also a Spark SQL data frame. You could switch between multiple ones.
Is there a vision history to keep track of changes
I believe who made what changes. Yes, I believe it does.
Just keep track of cell runs?
And so whenever you run a particular notebook, it keeps track of that, right? And I think one thing I did mention here is previously I mentioned about ML flow, right, for operationalizing machine learning. And so in order to use ML flow, this is the entire. All you need to do is import the library and say start of the run, and you can log a few things. And so in this case, I'm saying I want to be able to just capture a metric called accuracy. And so the accuracy for this model that we ran is what I want to track. So in the next part of the demo, I'll actually show some of these, how this things fits together, and you can track them even from a machine learning perspective. And so here, from a collaboration perspective, you can see about the runs and the revision history. From a jobs I've shown earlier, you can see the job history, the execution. Click on a notebook, and you can actually see the entire run and the output of each cell for when the notebook was executed.
Any other questions?
All right. And so now that you've created your model, right, the next part is operationalizing, which is now. And so this is the second notebook where which basically uses that model, takes the transactions for that hour or day, and then does the scoring on that particular one. And so in this case, yeah, you can see that it has actually predicted whether the transaction is fraudulent or not, right? And so again, using some of the visualization tools as part of this notebook, you can actually see in a visual manner how many of these were during which hour most of the fraudulent transactions have actually come in, right? There's also a couple of other interesting things on this particular on any notebook that you can do. You can actually click on this view and say create a new dashboard. And so each of these cells can again be created as a dashboard, and you can actually expose it to some of your business users to just view as a dashboard without having any execute permissions or without having to understand what exactly was going on in this notebook. And so it's kind of like almost like a built-in dashboard that one could potentially use. Oh, absolutely. And so from within Tableau, we have a Tableau connector that would be able to query both Spark SQL tables or even Delta tables. And so you can directly query directly from Tableau or any other BI tool. And so we have, no, you can't use these components. You can't use this. And so if you're using Tableau or Click or any other BI tool, of course you are using their components, but you would be able to get or get data from Databricks. And so you'd be able to query like a Delta table and be able to create visualization node there. So I mean, there's a lot of functionality within the visualization tool, even in the notebook. But I mean, if you when you're looking at like a Tableau or something, that of course it has much more richer one that for certain enterprises and for certain use cases. And so here, I mean, as part of the platform too, it allows you to do enough visualization to be able to collaborate together across the various personas that we talked about. So I think I wanted to show one more thing here. I did mention about ML flow earlier, right? And so we have ML flow keeps track of all the various runs. I mean, not just about deploying. Say, for example, I think I had a question earlier uh, uh, from a gentleman here where he said, I might be using some own frameworks. I might be using some certain machine learning libraries of my own. Uh, with respect to ML flow, it helps you operationalize that. You would be able to, whether if you have hosted something on GitHub, for example, your model or your uh, uh, Python code is actually there, you would be able to utilize those as part of ML flow and still be able to operationalize it. And so as what you see on the screen is basically the details on the various runs. You can actually yeah, click on anything to look at some of the data that we have logged. And so in this case, for this particular model, we logged the accuracy. And so you can actually look at the accuracy over time. ML4 is also as part of the Databricks platform. It is very tightly integrated with Delta. And so what this means is now a data scientist can, when you're looking at a model, right? It's, I mean, have this data. I mean, I ran this model. I got this accuracy, or this was this. But my model from a couple of days ago was supposed to be actually was working much better, right? So if you want to do some kind of an analysis like that, you could actually use the time travel feature that is available as part of Delta, be able to query the data as of that particular when the model was executed, right? Now you have the complete picture of what exactly happened at that time when the model was executed, when those fraudulent transactions were detected. And so this is a very powerful feature. And so having all of these features as part of entire platform helps you to be able to more effectively do not just from data engineering, but also be able to do machine learning and AI. So any questions? So, Robert, do you want to just show a little bit more on anything on Talend on the UI about these jobs? I know we went through a couple of them.
Well, let's look at all of them. Oh, Mac.
You want to show about how the data masking? I think that's a very interesting one.
Yeah.
So I think it's on the same.
Yeah. Cancel. All right, so data masking is kind of an interesting component. We actually allow you to pick the actual records or fields that you want to obfuscate by just clicking the green plus sign. And then there is a big amount of things that you can do on a per field basis. So if it's a social security number, do you want to scramble all the numbers and leave the format and stuff like that in there? Do you want to basically obfuscate the beginning of an email address and make it all X's and then at google.com or whatever? So data masking is really powerful, but I would like to talk about it. It's kind of a one-way street. It's not encryption. And if you obfuscate something, you want to put that into kind of a temporary storage for unauthorized users to see that data, but not see it in its full. You're still going to have copies of the original data in a secured place. You're just going to mask that data as you distribute data sets to individual users.
Yeah, and I think it's in our use case, for example, right? We are masking some of the credit card details because a data scientist, for example, who is actually creating these models, would not need access to actual credit card numbers or personal information of users. All they would require for features is certain information that would enable them to be able to better predict fraud, right? I mean, they were interested in features like where did the transaction happen at a particular ATM in a particular location? So location details, yes. They would not require details about where a date of birth of a user, right? And so by using this masking, even the data, when you're at the time of ingest, we are making sure that we are not putting personal information at risk at time of ingest itself.
So you've already talked about the notebooks. Let's talk about, let's see if we can zoom this a little bit. Is that better?
Yes.
All right. So it's hidden right now, but in our palette, we basically have components for different sources and targets. Salesforce is the example here, all right? So the steps that we went through is we created a connection, stored our Salesforce information, how to access it, what the URL is, username, password, stuff like that. And then we retrieved all of the fields from that particular module. This is the account module. It could have custom fields in it. We would bring those in and you'd be able to integrate with them and stuff like that. But now what we're doing is we're basically doing a join between accounts and contacts using our TMAP component, dumping that into a delimited file, and then moving that to the Databricks file system. Does the flow make sense? Okay.
So I think, yeah, these are different types of pipelines in which you can either you're ingesting data into S3 or ADLS or Databricks file system. Databricks file system is just an overlay on top of S3 or ADLS, right? Where you can actually map it to a particular storage account or a bucket on S3, so that you don't have to put the entire details and then it will automatically map to that.
I know this is an eye chart, but you know, doing mapping is really pretty simple, and doing lookups is pretty simple. So let's minimize this guy. The point is, I dragged one or more values or rows or fields from my input to my join table, and that's where the purple key is. And then once I have that join established, those two yellow lines down below are related records that's flowing into the output. Good? Anything else? Don't save it.
Yeah, I don't want without saving. Yeah.
Yep.
So a couple of key takeaways, right? I think what we have seen during this demo was we have seen how we could use Talend, and using a visual drag and drop approach, you are able to ingest data from a number of sources. Ingest data from multiple sources into Databricks, and then also to do your data engineering at scale on a managed scalable cluster on Databricks. And so with Talend, in a visual manner, you've created your data integration, and it gets pushed down as a Spark job on Databricks without you having to write any code, which is very powerful. This helps you to increase the number of people who can actually do data engineering at your organization, and much more very efficiently.
All right, so I just kind of want to conclude, we are trying to appeal to different personas who are involved in big data projects. Your data engineers that are moving data around, cleansing it, stuff like that, they're probably going to use Talend a little more than Databricks. Your data engineers, or not your data scientists, who are really into the Spark and Scala and R, and you know, kind of looking for those needle in a haystack and making models and training models and measuring predictability and stuff like that, They might use Talend a little bit, but mostly the Databricks interface, right? And then finally, your casual business user, they might not use any of the solutions at all. The links to the BI and Tableau and all that, the dashboards, that might be all they're interested in. But the point is, we are advocating and proposing a cohesive solution that really is end-to-end. It saves time and money in many different ways, but especially not having to hire your own big data people and not having to basically procure your own compute environment. With that, are there any questions? Yes.
Maybe I just missed it, but where's the machine learning output?
And so that was the scoring of the model. So we created the model, and so so the question was, where was the machine learning output? And so as part of this demo, what we have shown is that we have created a model, and for the data that came in, say for example, in the last hour, we ran the model again that we did the scoring, and then created the visualization on the fraudulent transactions that have arrived in that particular hour. No, not the visual. That's the output, and so the output goes into a table. And so potentially, like when you see in real life, what would happen is data is streaming in via basically this would be this data that actually streams in. The fraudulent transactions are put into a delta table by streaming job. And so when you look at the visualization tool, you'd be able to see at real time the transactions that are actually fraudulent at any point of time.
So, in other words, you taught the computer how to recognize
Yes,
fraudulent transactions.
exactly. And then we are exposing it via visualization for business users.
So there's more food back there, help yourself. There's more people in the room, help yourself to networking. And I want to leave you with one final thought. We've talked a lot about drag and drop interface, just don't step in the drag and droppings. Thank you.